In the last video, I talked about the default method and why it's such a welcome improvement to Java. It lets us extend an interface's functionality while staying backwards compatible. Another enhancement that Java included in JDK 8 was support for public static methods on an interface. Before JDK 8, an interface would often come packaged with a helper class that provided static methods. With this change, the static methods can be included on the interface type itself. Static methods don't need to specify a public access modifier because it's implied. When you call a public static method on an interface, you must use the interface name as a qualifier. In the ArrayList lectures, you may remember I used two static helper methods on the comparator interface which were added in JDK 8. These were comparator.naturalOrder and comparator.reverseOrder. Let's see what this really means when we create a static method on our own interface. This time I want to work with the Orbit Earth interface, and I'm going to add a method to log data to the console in a flexible way. Static void log with a string called description as a parameter. var today equals new java.util.date, and then I'll print the date and description. Notice here that I didn't specify public. I could have, but it would just be redundant, as I discussed earlier in this section. All methods on an interface are public unless otherwise specified. I'm using java.util.date, a class I haven't covered yet, but will in an upcoming lecture in much more detail. What I want you to see here is that I'm using the fully qualified name and not waiting for IntelliJ to add the relevant import statement. There are two classes called date in Java's libraries, one in java.util and another in java.sql. This is one way to do it. If you choose to have IntelliJ generate the import statement, make sure to use the date class in java.util. I wanted to show you an example of using a fully qualified name. You might do something like this if you're only ever referencing that class once in your code, as I'm doing here. If we create a new instance of that class, it gives us today's date and time for our own local time. So that's pretty handy. I'll call that method from the main method on the test class. OrbitEarth.log passing testing and a new instance of satellite. Let's review the output. As you can see, the date and time printed out. The format it is showing is what's called longform. I didn't override the toString method on satellite, so we got the default output for that class. That's not complicated, but the inclusion of public static methods is a definite bonus. It allows us to include helper methods on the interface type itself, as I've shown here. I've covered a default method and a public static method introduced in JDK 8. It wasn't long before developers were requesting more. JDK 9 gave us private methods, both static and not static. This enhancement primarily addresses the problem of reuse of code within concrete methods on an interface. A private static method can be accessed by either a public static method, a default method, or a private non-static method. A private non-static method is used to support default methods and other private methods. Getting back to the log method on Orbit Earth. I can also make this method private and static, which means only methods on this interface can actually call it. I'll do that now. Like any private method, static or otherwise, this means it's only available to be used by the interface's concrete methods. But as a result of changing the access modifier to private, I've got an error in my main method of the test class. I'll comment out the line where I'm using it. While I'm in this class, I want a method similar to the in-flight method, but which is more specific to things that orbit the Earth. I'll copy the in-flight method and paste a copy below, renaming the method to orbit and changing the parameter type to orbit Earth, which is the name of the interface I just changed. I also want to remove the transition method and that if statement. I'll explain why in a moment. Right now, the only class that implements Orbit Earth is Satellite. This class actually doesn't do anything for any of the methods. It overrode the methods, but I didn't include any code in them yet. Going back to the main method on the test class, I'll now add a call to Orbit and pass it a new satellite, which I created in a previous video. And now if I run this code, there is no output from that change. Nothing gets printed out from any of the satellite's methods. Before I work on those, I want to create a private method on Orbit Earth called logStage. This method won't be static and will take two arguments. The first is a flight stages variable, our enum, that represents the stage of the orbiting vehicle. The second is a string for the description. I'll create a string using stage and description, and assign it back to description, and then make a call to the log method passing description as the argument. In this code, I'm just prefixing the stage to the description that was passed. We can only use a private method from either another private method or a default method. I want to override the transition method that was on flight enabled, doing that on orbit Earth. I'll generate that overridden method. Let me change this code a little bit. Flight stage's next stage equals flight enabled dot super dot transition, passing the stage as an argument. I'll then call the log stage method and then return next stage. First, I'm assigning what comes back from flight enabled's transition method to a local variable called next stage because I want to print it out. I do that on the second line, passing the current stage as the first parameter to the private method and appending the next stage to the text in the second argument, and then return the next stage variable. Okay, so now it's time to have the satellite class actually do something. First, I want to add a stage field to the satellite class, which has the type of our enum flight stages. Flight stages stage equals flight stages dot grounded. Our satellite is going to have each stage set as it cycles through the flight stages. The only thing left is to implement the rest of satellite's methods. For this, I want a private method on satellite also called transition, but this method isn't overriding the interface's default method, it's overloading it. Remember, that means I'm changing the signature, so in this case I'm passing a string and not a flight stages variable. I'll print out description, make a call to the transition method and pass its stage, and then I'll call the track method. The method parameter is just a description that gets printed out. Then I set stage using the orbit Earth transition method. Now I could have just called stage.get next stage here, but you can imagine that when you're transitioning from one flight stage to another, there's some other work involved. And maybe a transition might fail and you'd want to deal with that. In a real application, you'd probably have support for these kind of different transition stages. On the last line, I'm calling track for each stage. Remember that our enum type is really trackable, meaning every stage is trackable in some way. I now want to put some code in the three remaining methods, takeoff, fly, and land. First, the takeoff method. Here, I just make a call to our transition method with the description we're taking off. And then the land method will do a similar thing, calling transition with the description landing. And now for the fly method. Here, I've also got a call to achieve orbit, because flying for an orbiting vehicle consists of two stages, the launch, then achieving orbit. And then I call transition again. When a satellite has achieved orbit, it can start collecting data or taking photos and so on. For completeness, I'll change the code in achieve orbit so it calls the transition method as well. There's the setup. Let's see what happens when I run it. You can now see all the stages get cycled through, including going back to grounded at the end. Notice that each stage is trackable, so you're seeing that with the monitoring launch, monitoring cruise, and monitoring data collection statements there. We've covered a lot of ground with this set of code, so be sure you take some time to try to understand it before you forge ahead. The best way to do this is to make changes of your own and get in there and explore it. Maybe add some other flight stages or different methods to some of these interfaces. Use a variety of default, private static and private static methods. See what modifiers are needed and which are redundant. See what modifiers clash. Try different access modifiers with the default method, for example. I can tell you a lot of things, but it's working with the actual code yourself that's going to help you remember a lot of it. Okay, so the next video is going to compare these two abstract types side by side, namely the abstract class and the interface. I'll see you in that video.